We're going to be looking at the parent function of the sine function. So we're going to be looking at the parent graph, in other words. Now, in order to do this, let's understand component by component first what each of these represents. So let's go ahead and take a look. I first will have the function y equal a times the sine of k times x minus b. Okay, now this represents what we call the phase shift form of the function. We won't be talking much about phase shift in this video, but we will save it for another video. So this is again the phase shift form. So when we take a look at this phase shift form, let's dissect everything component by component. The first thing we're going to note is A. A represents what we call the amplitude. So if this is the amplitude, we consider the absolute value of A. The amplitude will tell us how much the graph will stretch, okay, and in which direction. If it's negative, it will be reflected across the axis. And we'll make note of that when we actually graph a function in just a bit. K represents what I call the period modifier. The period is the length of the cycle of the graph. So the period is modified by k in terms of you take your period of the sine function, which is 2 pi, the parent, and divide it by k, the value that we see here in the phase shift form. Okay? B is what we call the phase shift. So the phase shift here, B, tells us which direction we will move the graph, whether left or right, and it's always going to be opposite of the sine. So again, once again, this is the phase shift. Okay, now we're going to dive in and we're going to take a look at the graph of the sine function, y equals sine of x. But first, we need to take a look at the unit circle. So now we see here that we have a copy of the unit circle in front of us. We're going to use this copy so that we can graph the parent function y equals sine of x. Now in order to do this, we're going to take a look at the values of sine from 0 to 2 pi. And we're going to look at some important marks on the graph that I've already laid out for you here and investigate those values. The first thing we're going to do is take a look at the function sine. And we look at the sine, and it is the y value on the unit circle. So we take a look at the y value first at the point 0. So at the point 0, at 0 radians, the sine corresponds to this value 0. So we'll put a mark here on our graph at 0. Now we look at the next value, pi over 2. We notice the sine at pi over 2 is 1. So let's go ahead and designate this point right here about 3 units up to be 1. Okay, just for the sake of scale. Now at pi over 2, I will put another point for 1. And then I'm going to look at the next value, pi, which is on my chart here. And the value that I'm looking at is 0 for the y. So I'm going to put a point there at 0. Now I'm going to look at 3 pi over 2, and my y value here is negative 1. So again, we're going to put a corresponding y value down here about 3 units down to represent negative 1, and put our point at negative 1 here. And then we go up again back to 2 pi, and we notice again that it cycles back, and we end up with a value of 0 once again. And so now what we do is we can connect these dots. So we look at this right here, connecting the dots. And what's important to note is that this is only one cycle of the sine function. It actually oscillates, it continues, and it repeats to the left and to the right of 0 and 2 pi. So one cycle of sine is equivalent to 2 pi units. So it takes 2 pi units in order for it to repeat its cycle. This corresponds to its period. So the period of the sine graph is 2 pi units. The amplitude is the measure of how high and how low the sine graph rises. Well, if you notice here, it goes up 1 unit, but similarly it also goes down 1 unit. This is why we always consider amplitude in terms of absolute value. So it stretches up 1 unit and it gets pulled down 1 unit. So the amplitude for the sine function is 1. Now let's go ahead and move our unit circle out of the way and take a look at a function that we can graph very similarly to this parent function. Now let's take a look. When we look at this graph, we notice that the amplitude has not changed. Okay, the graph will not be shifted left or right. However, the indication of this value right here that corresponded to k in our phase shift form will modify our period. So what we're going to do is we're going to identify the tick marks, and when I say tick marks, I'm referring to these marks here on the graph. Identify those tick marks so that I can go ahead and graph my function. So once again, let's make some notes about this graph. The first thing to note is that the amplitude has not changed. It is still 1. Okay? What has changed is the period. So the period, as we noted before, is modified by k, and k in this case is 3/2. So we're going to take 2 pi and we're going to divide it by the k value, which means that we're going to take 2 pi and divide it by 3/2. What this corresponds to is 2 pi multiplied by 2/3. So the period length becomes 4 pi over 3. So the graph of the sine function will actually end at this indicated point here, 4 pi over 3. And of course, when I say end, I just mean the cycle will end. The graph actually will repeat itself. Okay, so now let's figure out how to come up with those little tick marks. And I call them tick marks. You might call them steps. But for the tick marks, okay, as I'm going to call them, you take the period and you divide it by 4. Okay, that will give you the increment of each step. So you take the period and you divide it by 4. In this case, we have 4 pi over 3 divided by 4, which is equal to 4 pi over 3 multiplied by 1/4. And what ends up happening is those 4's cross out and you're left with pi over 3. So if we were to zoom in here on the graph, each of these marks would represent pi over 3 units. We start off with the first one, which is pi over 3 units from 0, the origin. Then we have 2 pi over 3, and then we have 3 pi over 3, which corresponds to just pi, and then 4 pi over 3, which was already given. So now we can zoom out. Let's go ahead and take a look at that graph one more time. We're going to make our points. Again, we start off with 0, just as in the parent function. So let's slide over and take a look at that parent graph so we can see how it corresponds. At the second value, which for us is pi over 3 and in the parent was pi over 2, we hit the amplitude of 1. At the third value, which in the parent graph was pi and in our graph here is 2 pi over 3, we hit 0. Okay. At the fourth point, we hit pi in our graph, which corresponds to 3 pi over 2 in the parent. It hits -1, again the lower version of the amplitude. And then at the end of the cycle, 2 pi in the parent graph, 4 pi over 3 in our graph, we hit 0. So now that we've done this, okay, we will then connect the dots. And it's very, very similar. Okay, so when I'm teaching this to my students, I hope that they just gain a very conceptual understanding of how to graph. Okay, that is, you should understand how to modify all of these components here and then be able to graph the function. Okay, it's not so much that it needs to be technical and precise. It's more about, do you understand the concept of the graph? And that's the factor that I can't stress enough. So as always, I hope this video was helpful, and remember, like and subscribe.